5.4, the derivatives of sine and cosine functions. This is one of my favorite lessons because I guess I'm just a big fan of trigonometry. But I hope you'll be able to be really good at this by the time we finish this lesson. So let's take a look first of all of the original function, y equals sine theta and y equals cos theta. And what we're going to do is draw the derivative functions right below it, just like we did previously when we were doing some sketching of derivative functions. So remember that where there is zero slope, that means it's going to be 0 on the derivative function. So I dot these down, and hopefully I've got them pretty straight. So there's my two zeros. Now if you look at the slope on this side of the function, it is positive and decreasing to 0. Remember the old trick of using your ruler. Let me just get something straight edged here. So it would be like, this is the steepest here, so it's like 2, 3, 1, 0. And then, of course, where we turn around, that becomes a point of inflection. So that becomes where we have the most negative. So on this side, it's going to be negative. There's the most negative and back to 0. So that means that this point right here is going to be the most negative point. And let's just kind of dot that one down. It's going to be the most negative point on the graph. And so on this side, again, we were positive to 0, and then we were negative and turned around, and then we came back up. And then from here, it was all positive again. So I think you can tell me, what is the derivative of sine theta? So y prime equals, it's the cosine function, isn't it? Cos theta. And so let's take a look at what happens if we take the derivative of the cos function. Now don't jump to conclusions here. Let's find the zero slopes. So there's one here, and one here. It's looking good for a sine function, right? With three zeros here. On this side, we have negative slope. Here it is the most negative before it starts going back to 0. So let's take a look again with the ruler. So it's negative, 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 most negative, and then now we're underneath the curve as we come back to 0. So this is going to be the most negative point. So we're like this. And here is going to be the most positive point. And we end up with this graph. Okay, so it's kind of a sine function, but it isn't. It happens to be the negative sine of theta. Now, one easy way to remember which one is negative is that every time the function starts with a c, if it's cosine, cosecant, cotangent, all of those derivatives are negatives. Okay, they're all negatives. That'll help you to remember. Okay, so now another really important thing that you need to know right away is that if I had something like this, y equals cos squared of 2x, what you need to know is that this squared means everything squared. So I write it like this, 2x squared. So it's the function with its angle that is squared. So this is very, very important. Very important. If you got this, then you'll be able to follow along with what we're going to do. Okay, so I want to take the derivative of this. So y equals cos squared 2x. So what I'm going to tell you is something that you need to remember. And if you forget, you won't be able to. You're probably wondering, what is she saying? Effa. This is what I want you to remember. Effa. E-F-A. Can you guess what these things start for? Well, A, let's write that one because I've got my green pen out. This is angle, right? Angle. not angel, but angle. F, that's the function. And E stands for exponent. So I taught my students to say effa. If effa you forget, Miss Havert will be mad at you. Effa, effa. Okay? Now watch how that works, and this makes this very easy. When I go to take the derivative, I'm saying effa to myself. I look, is there an exponent? Yes, there is. It is 2. So I do the exponent first. So it's like chain rule, right? 2 cos 2x. So I put the exponent to the front, reduce it by 1, leave everything alone, right? Leave this alone. And now I do the function. So the cos of 2x becomes the negative sine of 2x. So now I did the function, leave the angle alone, and then last I do the angle. The derivative of 2x is 2. So simplifying this, I have minus 2 times 2, so that's minus 4 cos 2x sine 2x. Okay, so it's very important, this exponent, function, angle. Okay, so I'll do a couple of examples where we go over exponent, function, angle. Some of them in your homework are easier. They don't have any exponent to deal with, but sure as God made little apples, the ones on your test will. Okay, so let's go to a nice blank page here, and we're going to do this function, which is y equals the sine cubed of the cube root of x. Okay, so we've got lots going on here. And first of all, I want you to move the exponent to be outside the bracket. So you will remember to do exponent, function, angle. So this is my angle here, right? What did I do for colors? So this is my angle. Whoa, rolled out of my fingers. So this is my angle. My function is sine. This is function. And the other one here, which I did in purple, this is my exponent. Okay, so let's write it out in proper order. So I have sine of the cube root of x, that's my angle, and the whole thing is raised to the third power. So to write this out first before you take the derivative. Okay, so now I'm going to say what y prime is. Y prime equals, do the exponent, so I write 3. Leave all of the rest alone. Just rewrite it. Now I'm going to do the function. The derivative of sine of the cube root of x is going to be cos of the cube root of x. Remember, the one that goes negative is cosine. And now I need to do the derivative of the angle. So I have the cube root of x. So let's do that over here just for a minute. So the cube root of x is x to the 1/3. So the derivative would be 1/3 x to the minus 2/3. Okay, so look what's in the denominator here, right? We have 3 cube root of x squared. Okay, so exponent, function, and then my angle was 1/3 x to the minus 2/3. And now I'm going to simplify that. So I have 3. All of this is in the top, right? This is all in the numerator. Let me just write that here. Numerator, and all of this is in the denominator. So I'm going to write 3 sine cube root x times cos cube root x. And then in the denominator, I have 3. Remember, this is your index number, so that's the number in front of x squared. Okay, and finally, I can simplify these, divide those out, and this is my answer, what is left. Okay? So exponent, function, angle. So let's do another one here. I'll write it out in pink again. So I have y equals cos 4 x squared minus 1. So I'm doing all the hard ones because if you can do the hard ones, you can do the easy ones, right? Okay, so here's my angle. The function is cosine. The cos is my function. And the function, of course, is all of this, right? It's the function with its angle. And then this is the exponent. You never just say cos. Okay, so rewriting that, that would be cos of x squared minus 1 all to the power of 4. And now I'm going to take the derivative. So I do exponent first. Remember, exponent. So I put the 4 out front. I leave all of this alone. So I have cos of x squared minus 1. Reduce it by 1, 3. The exponent is done. Now I do the function. Cos goes to negative sine and leave the angle alone. And now I do the angle, 2x. So I did the exponent. Here's the exponent. Here's the function. E, F, A, F, A. F, A, F, A. Angle. There you go. Exponent, function, angle. Now, of course, you would simplify that just a little bit more. I have negative, like pull this negative out, right? I'm going to take this, this, and this. So it's going to be negative 8x. And then you could write it as cos cubed of x squared minus 1 sine of x squared minus 1. Okay, so moving on to bigger but not necessarily better things. We're going to talk about some of the homework questions, and in particular it's question 3. I'm going to start with 3b, and it gives you that f at x is equal to x plus sine x. So we're getting in a little bit of trig here, where x equals 0. And I think the question asks you to, it does, find the tangent at x equals 0. Find tangent at x equals 0. So the first thing you need to do is take the derivative and find the slope at that point. So you're doing the same work you've always done, so don't get confused. So I take the derivative, f prime x, and that's going to be derivative of x is 1, and the derivative of sine x is cos x. So what's f prime at 0 going to give me? Well, it's going to give me 1 plus the cos of 0. And if you remember the cos of 0, there's my cosine function. Cos of 0 is 1. You can always plug it in your calculator if you're having a little memory lapse. Okay, so my slope is 2 when x is 0. So slope equals 2. My point is x is 0. What's y going to be? Because I need my coordinate, right? I need x and y and the slope. So I can use y equals mx plus b. If I put in 0 into this equation, f at 0, so let's try f at 0 is equal to 0 plus the sine of 0. Well, what's the sine of 0? 0. Everything's 0. Okay, so I have a point, 0, 0, and a slope of 2. So if I said 0 equals 2 times 0 plus b, I end up with b being equal to 0. So that means y is equal to the slope, 2x. And that's the equation of your tangent for that. Okay, let's do one that's a little bit harder. Same type of question, but in this one they ask you, they give you a little more difficult calculation to work on. And it's question 3e, and it says that f of x is equal to the cos of 2x plus pi over 3. And they want you to find the tangent at x equals pi over 4. And they want you to use exact values, I think is the actual terminology. Let me just see 3e. Determine an equation for the tangent at the point with the given coordinate for each of the following functions. Okay, so that's all they're saying. Okay, so tangent at x equals pi over 4. So I want to know what is f prime at pi over 4. Right, that's the first thing. But I'm going to first take the derivative. So f prime of x equals, so there's no exponent here. Well, there is one, but it's only a 1, so we don't have to worry about that because it's the cos of this angle. So I don't do exponent, but I say it in my head to make sure. Exponent, no. Function, yes. Cos goes to negative sine. Leave the angle alone. And then that's the function. Now I need the angle. The derivative of the angle, remember this is a constant, so the derivative of 2x plus pi over 3 is just 2. So that leaves me with minus 2 sine bracket 2x plus pi over 3. Now I want to know what is the slope at pi over 4. So I want f prime at pi over 4. F prime at pi over 4. So that's minus 2 sine, and I plug pi over 4 in for x. That's going to give me 2 times pi over 4 plus pi over 3. So what is that going to come out to be? So that gives me pi over 2 plus pi over 3. So make them over 6. That gives me the sine of 5 pi over 6. Now can you tell me, remember how to find the sine of 5 pi over 6? Let's make a little coordinate plane here. So 5 pi over 6. The related acute angle is pi over 6. CAS. Sine is positive. So that is the same as the sine of pi over 6. So minus 2 times the sine of pi over 6. What's the sine of pi over 6? You should know that one off by heart. Pi over 6 is 1 over 2, right? 1/2. So pi over 6 is up here. That's 30 degrees, right? It's 2, 1, square root 3. And the sine opposite over hypotenuse is 1/2. So that's minus 2 times 1/2. And that gives me minus 1. Okay, so I have the slope now. This is the slope. Slope equals minus 1. I need my point. They gave me the x coordinate. I need to find f at pi over 4. So f at pi over 4 is going to be the cos of 2 times pi over 4 plus pi over 3, which is the same calculation we did here. So I know it's 5 pi over 6. The cos of 5 pi over 6. The cos of 5 pi over 6 is the same thing as the negative cos of pi over 6. Do you know why? Because I'm in this quadrant. The related acute angle is pi over 6, but cosine is negative in quadrant 2. So I have to write the negative cos of pi over 6, and that would be, the cos is root 3 over 2, so that's going to be minus root 3 over 2. Okay, so now I have slope and I have my point. My point is pi over 4 and minus root 3 over 2. This is my x, y, m. Now I use my tangent equation, y equals mx plus b. And I plug in everything I know. Y is minus root 3 over 2. The slope was negative 1. X is pi over 4 plus b. So bringing this to the other side now, I'm going to have minus root 3 over 2 plus pi over 4 is equal to b. And I should find a common denominator here to make things pretty. So that would be 2 root 3 plus pi all over 4. Or you could write it as pi minus 2 root 3. It doesn't matter. I'm going to write it this way first so you see where I'm getting to. So this is, 2. I have to make this 4, so I have to make this 2, and this is already over 4. So 2 root 3 minus 2 root 3 plus pi over 4 is equal to b. Okay, so therefore, I'm going to make my statement about tangent line. Y equals, the slope was -1, so negative x, y equals mx, -1x plus b. So plus, I think I would write it this way though, because it looks a little neater. Pi minus 2 root 3 over 4. And there is your solution to 3e. And that was a bit of a tricky question, right? It was a little bit longer than you might have wanted to spend doing one of your homework questions. Okay, so the last one I'm going to do for you, I think I might just flip my paper over here because I'm running very low on paper. Nobody provides it for me. So we make it nice and big. 5D, it says mx equals x squared plus cos squared x cubed. And they want you to find the derivative. So this is a little bit tricky because this has a power and this has a power as well, right? Cos squared x. Okay, so let's get to work here. M prime x equals, so let's do the chain rule first. 3x squared plus cos squared x reduced by 1, 2. Now I need the derivative of the inside. So the derivative of the inside, the derivative of x squared, nice and easy, 2x. The derivative of cos squared x. So that's like cos of x squared, right? So, whoops, that's not a bracket, it's a plus. So 2x, and now I'm going to do plus, let's take the derivative of this and write it in here. So I have 2 cos x, that's exponent. Now we do the function. Cos goes to negative sine x, and we do the angle, which is just 1, so I don't need to write that in. Let's make these a square bracket. Okay, so now what I have is this, 3x squared plus cos squared x squared, and then I have 2x minus 2 sine x cos x. Does that ring a bell for you? 2 sine x cos x? Advanced functions, trigonometry, 2 sine x cos x is equal to the sine of 2x. So in the back of the book, I don't know how demanding your teacher is, but some teachers would expect you to recognize that maybe this might be a little, not a bonus mark, but just to show that you understand and remembered something from grade 12 advanced functions. Okay, so that's derivatives of sine and cosine functions. I hope this helps you out, as always, and that you found this to be helpful before your next test. All the best. Don't forget to subscribe and tell everyone you know to watch the channel and be smart like you.